everybody, we are Group 12. In this project, we will implement the Asynchronous Advantage Actor-Critic algorithm. It's also called A3C to play the game Super Mario Bros. Our program is able to pass 24 over 32 stages of the game. We use Asynchronous framework to update the Advantage Actor-Critic algorithm. The global network collects the gradient from the workers and updates its parameters, while each worker copies the global parameters, then playing the game to calculate the gradient to update back to the global network. The interval to copy and update the global network from the worker is set as 50 steps. In this project, we use a single PC to run A3C. The PC runs 7 processes. Is equal to 7 workers at the same time, 6 for training and 1 for testing. About Super Mario Bros. Super Mario Bros. Is one of the greatest video games of all time. It's developed by Nintendo in 1985. Players use 12 actions to manipulate the Mario to run left to right and get the flag to finish the stage. There are 32 stages in total with different scenarios, enemies, and obstacles. Reward system. Instead of using the default reward, we design a new reward system to match the playing style. We give a small score when Mario runs to the right and penalty if it runs to the left. After 200 time steps, if Mario stays at the same X position, we force the agent to die for saving time. With our reward system, Mario is encouraged to go to the right to get the flag to finish the stage as fast as possible.
At the beginning, we train the agent on a set of stages of the first word, then doing transfer learning to the other stages. The figure shows the result of training phase. During the training process, Mario needs to reach the flag at X position of 2161 in stage 1, 2, and 3, and 2246 in stage 4 to accomplish the corresponding stage. After training, the agent finishes 3 over 4 stages in 6 hours and is stuck at X position of 756 in stage 4. The figure here illustrates the transfer learning time for each stage from the first word to the 8th word. Using transfer learning, the agent accomplishes 24 over 32 stages. We use these network parameters to train on the other stages. The result shows that the agent is able to complete the new stages faster. Some stages require new skills with new playing styles, and also the scenarios are totally different from the previous pre-training set. In addition, here are some videos to illustrate some challenging stages for our agents, such as swimming or exiting an infinity loops. At first, this is stage 2-2. It requires Mario to swim in this environment and dealing with unusual enemies such as fish and squid. Secondly, the looping stage such as say A4, it needs to enter a specific part to exit this infinity loops. And this is one of the tricky actions that our agent failed to explore.
To improve the performance of the agent, in the future work, we will use the hierarchical structure. We consider the game requires a set of skills to play. Then, in the hierarchical structure, each sub-policy learns a talent or a skill to play the game, while the master policy switches between a set of sub-policies. The skills that Mario needs to learn could be jumping over the enemies, getting the flag, or swimming. In this project, we introduced the Advantage Actor-Critic method, which is a combination of policy-based and value-based. By using advantage function, the algorithm reduces the high variance of the policy-based We then update the Advantage Actor-Critic method asynchronously to improve the performance by running many instances of the game and collect the gradient from the worker in parallel. We also do the transfer learning to fine-tune the agent on the stages. At the transfer learning, our agent can learn a new skill with new playing styles to complete a stage faster than learning from scratch. Finally, our program is able to finish 24 over 32 stages of a game. However, the agent still is stuck in some tricky stages like loop stages or stages require specific actions.